Hello again, everyone. So welcome to the pre-registration session. So let me just say a few words on, because we experienced some of you experienced some echo troubles. So there are two things you can try when if you experience such problems. You check for double tabs open in your browser or multiple browsers open, or the website. If you have LiveMEEG.org open, as well as another tab of Crowdcast, the video may play twice. So that's why you're hearing an echo. Now it's all yours. Please, Antonio, I'll leave you the stage.
Thank you. Can everybody hear me well? Good. Well, welcome everybody. My name is Antonio Schettino, and I am the coordinator of the Open Science community at Erasmus University and Erasmus Medical Center in Rotterdam, in the Netherlands. I have the pleasure to chair this session on pre-registration. I'm extremely excited because we have great speakers and amazing attendance. Like, we almost have like 1,000 people. I was really not expecting this. So I guess everybody is eager to begin, but before we begin, I would like to remind the audience that you can submit your own questions in the Ask a Question box below the videos. And you can also upvote other people's questions, and they will be prioritized and answered earlier. We will answer questions during the roundtable at the end of all the talks. So to make it a bit easier for everybody, you can use this format to write your question. I'm going to put it in the chat right now. It's not compulsory, of course. It's just, to see if it works for everybody. The idea is to have like a who section in which you can say to whom your question is directed. And these are the three speakers that you can answer questions to. The type, so how you want to ask the question, if you want to be asking it yourself live, or if I can simply read the question that you have written, and the content, of course, of your question. So just to give you like an example, I'll put in the chat as well, like something like this, something similar to this, doesn't really matter. Just to make things a bit easier for the admins and for ourselves. All right, so I would like to make a brief introduction so that everybody knows what we're talking about. What are pre-registrations? Pre-registrations are time-stamped, publicly accessible documents with the hypothesis, data collection plan, and intended pre-processing and statistical analysis written before the start of a research project, so before you start collecting data. There are two ways to pre-register your study. The first is to upload this pre-registration protocol on a trusted online repository, and one of the most famous ones is the Open Science Framework, which assigns them a date and a time. These protocols are made public immediately or after an embargo period. And then the second way to do pre-registration is to send your pre-registration protocol to a journal so that it can be reviewed. This is an alternative article format called register reports, and we're going to learn much more about this later on. Why are pre-registrations useful? There are many reasons. I'm just going to highlight a few. Pre-registration clarifies the distinction between hypothesis-driven and data-driven analysis. It prevents harking or hypothesizing after the results are known. They help disclose selective outcome reporting, for example, omitting some conditions or omitting some variables. And all this can help counterbalance publication bias and strengthen the evidential value of the studies published in the literature. So all in all, if you think of registration, think about them as something that increases transparency of the research workflow. This practice is getting more and more popular in many research fields. So for example, the number of pre-registrations uploaded on the Open Science Framework went from 38 in 2012 up to more than 36,000 in 2019. Also, register reports are offered as alternative article formats in more than 250 journals. And for the EEG people in the audience, which I think is almost everybody, Cortex, Psychophysiology, and the International Journal of Psychophysiology are examples of journals who offer register reports. This session at LiveMEEG is also evidence that pre-registration has become part of the mainstream discourse, and it's a tool to increase and ensure reproducibility in EEG and MEG research. The invited speakers will share their experiences with pre-registration as researchers and journal editors. And many thanks to all of you, all the speakers, for being here. The first speaker for this session is Dr. Sophie Herbst, cognitive neuroscientist working at the Cognition and Brain Dynamics team of the INSERM Cognitive Neuroimaging Unit. And Sophie will talk about her experience authoring a registered report for one of her EEG studies, and how this process helped her streamline choices related to data preprocessing and analysis, and also limit data-driven choices that could lead to false positive. Sophie, whenever you want, the floor is yours.
Can you hear me? Okay, great. I'll share my slides. Oops. Okay, can you see my slides? Can you see my slides? I can't hear anyone.
Now we are stuck in an endless loop. Yes, now
okay, fine. All right, thanks. I'll start now. Okay, thank you, Antonio, for this nice introduction. And you already helped me make some points, so I have more time on the to go into the example that I want to give. So I want to talk about pre-registered reports in MEG research and how they can help us navigate what is called the garden of forking paths, based on a recent experience I had when I pre-registered for the first time a EEG study in Cortex. So you've heard this before. Why do we need to change the way how we do cognitive neuroscience? So on this picture, you see p-values collected from published papers on the x-axis and their frequency on the y-axis, and I highlighted for you in red a peculiar observation, namely the p-value just below 0.05 sticks out in terms of frequency. That's not good. It should stick to the line like the other ones. So this indicates that there might be some unfortunate biases in published work. And some of these have already been mentioned. So why do we have these biases? Everyone who's ever done an EEG or MEG study knows that the statistical results depend on a sequence of decisions to be made by the researcher. This is what has been termed the garden of forking paths. And you see this in this little cartoon on the right. So you have all these different options and forks to take. And this becomes especially problematic because, first of all, it's not transparent. So not all of these might be reported in the published work. It's even more problematic if you choose as a criterion for which path you might want to take the final outcome. So as highlighted here, you would choose the orange path because it gives you the p-value that you want. And it can also lead to harking, which is you would end up writing a paper that discusses this orange path as if this would be what you would have planned originally. We've heard from Manuel about cognitive biases, such as hindsight and confirmation bias. We've already heard about underpowered studies that lead to inflated effect sizes. And we have maybe also heard about publication bias, which means that in the literature, I've shown us what this picture I showed before, that there's certain p-values that stick out, or there are more positive results than negative results. And all of these lead to the fact that we have trouble replicating our studies, and the scientific literature can not always be trusted, which is a problem. I want to highlight one point that I personally think is very important. So this is not to blame individual scientists for making these choices. I think it's very understandable, and we should not go after people and think they just want to do bad science. I think the real problem here is that we have a mismatch between incentives to advance scientific knowledge and incentives to survive in academia. So here I've put the chart from Gary Carter, and just to name a few of these examples. If you want to contribute to good scientific knowledge, you should publish negative results, while if you want to survive in academia, you should publish strategically Or the last one, you have an exciting novel result. Should you publish it right away, or should you run a confirmatory study to replicate it before you publish it? If you're on a 2 years postdoc contract, you might rather choose to publish it right away, because otherwise you wouldn't even have a chance to replicate it, because you wouldn't have a salary anymore. And so I think this is really a problem that we need to tackle. And I think that pre-registered reports or pre-registration in general can help us with that. So this slide, Antonio also mentioned that. I just wanted to mention that there are different types of pre-registration, going from, I put 3, because in France it becomes more and more common for example, master students having to submit a pre-registration in their internship early on. There are also the other 2s that Antonio already mentioned. So not peer-reviewed pre-registration, where you upload a document on the OSF or other websites. And then finally, peer-reviewed pre-registrations, registered reports, like in Cortex or Nature Human Behavior, where you have a full peer review prior to data collection, and you can obtain what is called in principle acceptance for publication, and it can possibly be made public early on or a bit later. So how can this help with scientific practice? It for sure increases transparency, because you outline a priori what you're planning and also which analysis steps you want to take. It reduces p-hacking, because you have to justify the path you take. Separates prediction from post-diction. It helps with better planning. For example, when you have to estimate the power of your study, you benefit from feedback early on in the project when you actually still have time to change your protocol. And it can hopefully speed up the analysis and publication phases and allows you to publish negative results. So I was trying to illustrate this in the this picture on the right-hand side. This would be the non-pre-registered version, where you have all these blue paths, which are not necessarily made public. And this would be the pre-registered version, where you have this orange path that you follow. You confirm your original hypothesis, but you also did an exploratory analysis, which gives you a somewhat different result, and you publish that, but clearly label the two to be distinguishable. So here's my example. This is a replication study of a seminal EEG experiment by Stefanic et al. In 2010 in the Journal of Neuroscience. And yeah, we obtained in principle acceptance for this at Cortex recently. So the original study is an auditory reaction time task, where you hear a stream of beeps. And the interesting manipulation is that there is a contingency between cue and target tones, such that there are 2 types of cues, high and low tones, and one cue predicts that the target will come early, the one marked in red here, and one predicts that the target comes late, the one marked in blue. Oops. In 2010, the study, they had recorded EEG from 13 electrodes, and they found a modulation of the delta phase angle by the endogenous expectation. That is prior to the actual target, so the time window you see marked here. You would see a difference such that the phase of the delta oscillation is more aligned over trials when you have a strong expectation that the target is about to occur. And it's less aligned when you have a less strong expectation. And this was an important study because of this endogenous modulation of the oscillation, which can be taken as evidence that the delta oscillation conveys temporal predictions. So what we're doing is just, in quotes, replication, but still there's some important differences. So we're using a different EEG recording system with 64 channels. We're using a different analysis software. We had to implement the paradigm again, and we try to improve the statistical analysis since 2010. The field has moved forward. So in principle, none of these should matter for the results. This is from the stage 1 manuscript. So you see here, I just made again a figure of the paradigm. And what is important to mention is that we recorded 3 pilot EEG participants for this during the pre-registration process. And you can see here that you have a delta-ish oscillation there, which is nice. In the pre-registered manuscript, we specified all the recording and pre-processing, notably just mentioning some important steps to give you an idea about the level of detail, and maybe we can discuss this later with Pia. So we just defined the frequency filters. They're very important for low frequency oscillations. We outlined 4 parallel options for filters to have comparisons and make sure the results do not just depend on trivial filter settings. We do ICA to remove artifactual components like blinks or blinks, using a semi-automated rejection procedure. Then we have a fixed rejection threshold for remaining artifacts, and we also use visual inspection in the end to make sure we didn't miss anything. So the point I want to make here is that these are quite a lot of steps to implement, and it's not trivial to come up with such a pipeline. We have in this study we have a set of hypotheses. 2 confirmatory ones, which we need to claim that the replication worked, and then a few more which are more exploratory. So the confirmatory ones are 1 behavioral, and then the one with the delta oscillations phase consistency that I explained before. And an important aspect of pre-registered reports is to have a stopping criterion, or to say how many power analysis, how many subjects you will test. So here we choose a base factor approach, where we will stop recordings when we reach either a base factor below 0.1 or above 10 for both of the hypotheses. They can go in different directions, so we can confirm one hypothesis and not the other, but they need to be both conclusive. And in the replication review process, we decided to restrict and actually these signs are the wrong way around. So it's more than 15 and less than 50. You have to imagine it's the other way around. And then we also defined participant exclusion criteria to reject a participant if more than 25% of trials are bad. So now I want to talk a bit about the challenges that came up in this process. So you see that there were lots of small decisions to be made, and some depend on, you saw some numbers, so sometimes you have to implement some hard cutoffs in a way. And first, not all of these details are available from the original paper, and for sure you need pilot data to make these choices, and you need prior expertise with e.g. data analysis. And then some of these still remain a bit you can only specify them on the group level, like the group statistics. So it left me with the feeling that all of this still remains a bit subjective, and notably requires substantial expertise by the researchers. So the question would be how we could train early career researchers to be able to do these pre-registrations. And of course, it delays data collection because you have to do all this, and if you go through the peer review process, it will take some time. This is not necessarily bad. So I think all of these can actually be turned into benefits, because you just shift the heavy load from the later phases of the scientific project to the earlier ones. So it requires you to thoroughly think about and plan all the steps to acquire pilot data and to acquire expertise before actually doing an EG study, which might be a good thing. A little remark about the review process. It was all very nice, and we got accepted in the end, so everything is fine. I was surprised that there were important discussions about the theoretical framework. So it's a replication, but still many questions came up, and really found this a very good experience, because it forces you to think through the study again, and I think this should be done more often. There were some selective improvements and suggestions on technical aspects, but I think it's also difficult for the reviewers to go through all the steps and imagine this hypothetical study. And there were quite some suggestions for alternative hypotheses and analysis, which I put in this little cartoon. And this might be maybe something that you get more when you do a pre-registration than when you have the final paper. So could you look at this? Could you look at that? And then it becomes tricky if you have too many hypotheses. So I'd like to end with some suggestions to underline the fact that I think pre-registration is very helpful, but I think there could be more good practices to accompany them to make it easier for the researcher and for the reviewers to really assess what is going to be done. There could be, or there actually are, pre-registration templates which list all the important steps. I put an example. This is for an ERP template. I didn't find anything for time frequency, but if something exists, let me know. So you list all the steps, and it makes it easier for the researcher and also for the reviewers to check whether you covered everything. A big step would be standardized data and analysis formats, from which we will hear more during this workshop, that would possibly enable the reviewers to actually look at the code and even have online executable code where you can replicate figures and things like that. And here's a little teaser for such a standardized analysis format at MNE Python. And Richard, who is in this picture, has a poster later on. So this is the MNE study template on which I've contributed with the Cognition and Brain Dynamics team to come up with a set of scripts that are flexible but standardized and allow you to do all the necessary pre-processing steps for EEG or MEG data. And the nice thing about it is that ideally you have a configuration file, where you just edit your parameters, and another researcher who is a bit familiar with this template would just have to look at your configuration file and would understand what you did. And I think, initiatives like this would be a really great add-on to make pre-registration even better. And another point would be to define criteria for clean data rather than absolute thresholds, for example, for artifact removal. I think we'll hear more about this during the later talks, and to make pipelines that are less user-dependent, such as automated or semi-automated procedures. So to wrap up, I think pre-registration, and in particular pre-registered reports, contribute to good, better, best, I'm a bit confused with these terms now, scientific practice. They can help align good scientific practice with reaching academic incentives, and I think that's a very important point. They foster rigorous scientific thinking early in the project. They emphasize the early phase of a project and hopefully shorten the last phase, and I will update you on this probably at the next Cutting EEG conference. Pre-registration requires substantial experience with the analysis prior to data collection, which is something I think we need to address, and can be facilitated by standardized analysis pipelines, data formats, and templates. With this, I'd like to thank the organizers and my collaborators and you for listening. Thank you.
Thank you. So I had to kill my my camera because there's a problem with the visualization of the slides. So I will not subject the audience to my ugly face anymore during the presentations. But I would like to thank you, Sophie, for your perspective, because it's really clear. I think you touched on a number of issues and ideas that we can explore later. First of all, there is a social aspect in our academic jobs, and that is not necessarily related to the to the best practices or the good practices that we are trying to implement. And I think it's worth discussing if we have time. I think it was also interesting to see that despite the fact that this was a replication, so in theory an easy thing, it was quite complex because some information was missing, or it was unclear because things improve over the years. And also your emphasis on pilot data, I think, is really great. It's something that I've also noticed myself when I did my own registration. And I think two other things are really nice before I leave the floor to our second speaker. The usefulness of templates and the standardized pipelines and data formats. So the idea of maybe having like a data formats like bids, structures, have standardized pipelines for pre-processing of the data. And also the second thing that I really like is like how was your question, how to train early career researchers to do pre-registration, because it requires quite a lot of expertise. So for now, if you don't mind, we just keep it, you know, like in the air, so that people can also think about these things, and then we go for the second speaker. Well, thanks again.
Thank you.
So the second speaker is Dr. Ronnie Thibon, a postdoctoral researcher working at MRC Cognition and Brain Sciences Unit at the University of Cambridge. Ronnie will present a novel format for scientific posters called pre-reg posters and review data collected at the BNA 2019 Festival of Neuroscience, where these pre-registration posters were implemented. So Ronnie, whenever you're ready.
Okay, thank you. Sorry. Okay, can you see my screen? Can't hear anything?
Yes.
Yeah,
yes.
Okay. Okay. Hi, thanks, Antonio. So yes, I'm Ronnie. I work at the MRC Cognition and Brain Science Unit in Cambridge, and my research focuses on the human memory. I test younger and older adults, but today I will tell you about this recent initiative that kind of can be shared across fields and across methods. And this is the idea of pre-reg posters. So pre-reg posters are conference posters that present planned scientific projects rather than completed ones. And to some extent, this idea was actually inspired by the concept of pre-registration that you've just heard about, which is how it got its name. However, in practice, we realized that it's quite different and allows for different and complementing advantages that I will talk about today. So in the next 15 minutes or so, I'll take you through the background for this idea of pre-reg posters. Then I'll talk about the theoretical advantages of these posters and where we place them within the context of pre-registration and open science more broadly. Then I'll show you some evidence from a survey of the popularity of these posters. And finally, I'll discuss some future considerations for conferences and for delegates that want to adopt this format. So the background for this was when we thought about submitting an abstract to one of the major cognitive neuroscience conferences. And I finished data collection maybe just a week before submission deadline. And the problem was that the guidelines for abstract submission strictly said that the abstract should include results and discussion. And after looking at guidelines for several major conferences, we realized that typically the conference rules say that the abstract must describe completed work. And yet the deadline for abstract submission is often several months before the conference itself. And as a consequence, by the time the work is presented at the conference, it is either published already, at least as a preprint, in which case it's not really news anymore, and there's only little room left for feedback. Or in some cases, it could be that the results in the poster have changed quite dramatically from those described in the abstract, because the authors have been rushed to submit their abstract. And as a result, the relationship between the study as it is described in the conference program and the results themselves look a lot like this. So in this paper from 2018 with Rick Hansen and the Open Science Committee of the MRC CBU, we describe this problem and we offer several solutions. And in general, we propose to have several submission categories for posters, depending on the stage of the project. So here you can see this really nice implementation of this idea by the Cutting MEG conference, which was postponed. So here there are 3 submission categories. The first is the planned study. And in this category, you would need to provide the scientific rationale at the time of the abstract submission and the full detailed protocol at the time of the conference, but no data or results. For the second category, you would need to provide a rationale and methods at the time of the submission. And then you can include results and conclusions at the time of the conference, but it's not mandatory. And then finally, this third category is what we see now in most conferences. So this is the traditional posters that include all of these components already at the time of submission, and then again at the time of the conference. But for now, I want to focus on this category, which basically is what we refer to as pre-reg posters. So as I said, this format of poster present planned work before data has been collected, or at least before it was analyzed. And this format has several advantages. So one of the main ones is the ability to get feedback from conference delegates who are often experts in the area. And this feedback will allow you to improve your design, modify the hypothesis, and optimize the analysis. Or it can even help you decide at a very early stage the study doesn't worth the trouble, and then save you a lot of money and headache later on. It also allows you to gain potential collaborators, so people who show their interest in the conference and can perhaps contribute to the project further. And then it can also help you publicize the precedence of your idea, which will appear in the conference program and can later be developed into a full pre-registration of the study. So overall, pre-reg posters can really improve credibility and rigor in science. And to explain how they fit with other similar suggestions, I want to take kind of a step back for a moment and discuss those. So basically, we see pre-reg posters as a step that you can take prior to formal registration of your project. So the idea is that you will present your pre-reg poster at a conference, or sometimes even at several conferences, and adjust your methods and predictions according to the feedback that you receive. And then you can submit the study as a registered report to a journal, or pre-register the study on a website like OSF. And as Sophie just discussed, these methods prevent common biases such as hacking and p-hacking, and they also provide a really great way to help you think about your study a bit more carefully. And then the next step would be data collection and analysis. And now, importantly, registered reports are locked in a sense that the researcher commits to the protocol listed in the report. And any changes or additional analysis are defined as exploratory. Pre-registration can be either locked or unlocked depending on the website that was used or the platform. On the other hand, one of the key features of pre-reg posters is that they're not locked. So the idea is not that you commit yourself to what you presented to the poster, but that this will be your opportunity to get some constructive feedback and to improve your study, which can later lead to locked registration of the protocol. So pre-reg posters were allowed at the BNA Festival of Neuroscience in Dublin last year, and we're really happy to see that 100 posters out of about 500 adopted this format. And we did a survey both before and after the conference. And this survey was ran by Anne Cook and Kimberly Browse from the BNA. And you can see all the questions and data here on OSF. And we published a paper summarizing these results that you can see here. And I want to take you through some of the highlights of these results. So first of all, there was no evidence that pre-reg posters received less visits or less feedback, or that delegates found them any less interesting compared to traditional posters. And the presenters, the presenters of pre-reg posters felt like they got constructive feedback, which is really important because this is the main purpose of these posters. And as expected, most of the feedback that the presenters received focused on methods and design. Second, more than 60% of the submitters of pre-reg posters indicated that one reason they chose this poster format was to gain some experience and confidence with pre-registration and with registered reports. Many of them also indicated that they intend to pre-register the studies that they presented in the conference later on. So it looks like pre-reg posters can really promote open science practices. And then finally, there was some suggestion in the data that this format was more common from early career researchers. So this might be because young researchers are more keen to adopt research initiatives in general, but it also might be because they often need to have proof that an abstract was accepted in order to get funding for conferences. And therefore, the ability to present planned work might give young researchers more opportunities to attend conferences and to benefit from them. So this format is being adopted by a growing number of conferences. We already know of about 10, and you can see the full updating list here. And we think that now, when most conferences are held virtually, there might even more opportunities to adopt this idea, since there are basically no space limitations. And I think that one particular problem with online meetings is that it's really hard to engage with others. And perhaps posters in general, not just pre-reg posters, can be one way to deal with this. So for example, we can have breakup rooms that focus around posters that share some theme, or to open discussion forums for posters and so on. So these are things that naturally happen in face-to-face meetings, but are hard to achieve online. And then having poster-driven discussions are one way to do this. So this can be exciting times for posters in general and for pre-reg posters in particular. And then lastly, sorry about that. Am I back? Yeah.
Yes.
Okay. Yeah. Okay, so lastly, I want to go through some tips for conference organizers who consider this format for their conferences, and for conference delegates who are thinking of presenting pre-reg posters. So for organizers, it's very important that you inform the reviewers of abstracts about principles of pre-reg posters. Otherwise, they might give them lower scores compared to traditional posters, just because these posters don't include any data and results. It's also important to highlight in the program and on the posters themselves which posters are pre-reg posters. So one idea which was popular at BNA was to use badges, OSF badges for that, and we're actually working on a new badge that would be specific to pre-reg posters, so they're not confused with other formats of pre-registration. And it will also be very helpful if these posters can be submitted nearer to the conference time as late-breaking submissions, so the delegates don't have to wait too long before abstract submission and the initiation of data collection. And there are more great tips for organizers by the BNA that are available here. And then finally, for delegates, try to think before the conference what kind of feedback you'd like to get, so you can ask for it directly while presenting the poster. And in general, try to be proactive. So identify potential collaborators, ask for feedback, comment on other posters, and so on. And then after you present your pre-reg poster, don't forget to share your wonderful experience on social media. So I'd like to finish with a huge thanks to these people who helped bringing this idea to life and to show that it actually works quite well. And with this slogan, which came up in one of the Twitter discussions about pre-reg posters, the discussing science is not only about discussing the results. And thank you all for your attention.
Thank you. Yeah, that's really cool. So, I think it is, yeah, you have clarified the complementing advantages of pre-registration posters compared to, you know, like pre-registering like the whole study. And I also like the fact that there is, you know, like this idea of having these three different classes of posters. So like the distinction between planned, collecting data, and analyze data studies. I really hope it becomes the new normal. Because I think, you know, there will be a little bit more transparency compared to, you know, like sometimes, you know, pretending to have, you know, completed all your analysis when you actually only completed the strict necessary so that you could send the abstract for the poster out. I also like the fact that these posters are meant to be immediately public instead of being, you know, embargoed for a relative amount of time. Because otherwise it would defy the purpose of exactly registering the poster in itself. And I collect stickers on my laptop, so I look forward to seeing the new pre-reg poster badge. So please let me know when it's out. Okay, so there is now time. So in the program there is like a break scheduled. So we will come back at 10 to 5, if it's okay for everybody. I don't know if the admins have something to say about this. I'm not an admin. I'm just here chairing. Admins? Okay, I have the power then. All right. So then, yeah, let's come back at 4:50, and then yeah, we really try to follow the schedule and the program, and then we will hear our last speaker. Thank you. Slowly welcoming everybody back. I feel like I'm at the door of the hallway, in the hallway, and I'm welcoming people. Please, you can finish your coffee inside. Don't worry. Start again in a couple of minutes. Yes, I know you will. Don't worry.
Hey, there we are. We don't leave you alone, right?
No, don't worry.
No worries.
I've done this long enough.
Yeah, okay. So
now, so don't worry about me. I hope that the audience is enjoying this.
I think they're still there. Huh? I don't know how many of them it is, but yeah. Okay, and you see, we are really panicking here. They're trying to fix her computer, and okay, others are preparing coffee. Voilà, and Sophie. Allez, vas-y, I leave you guys.
So are there? Is everything all right? We can start in 1 minute, or you want me to wait? Okay.
Yeah, I think we're good to go, and I think we can go on and invite Pia on stage. I'll let you invite her.
Yes. So welcome back from your coffee, from whatever else you did. Let's jump right into it. Our third speaker is Dr. Pia Rothstein, lecturer at the School of Psychology of the University of Birmingham. Pia will leverage her experience as a member of the Register Report Triage editorial board at the journal Cortex, which was the first journal that implemented Register reports, to describe the process of submitting and reviewing a Register report. So, Pia, whenever you want to start.
Okay. Hello. Thank you for inviting me. Yes, I will be talking from my role as a part of the editorial triage register team. Obviously, we are a team, so this is the team. So the leader of the team, which is, I think, the person who is one of the people who is most known for Register Report and for Open Science, is Christopher Chambers. And then we have Sam Schwarzkopf and Rob McIntosh and Zoltan Dienz. I would say Zoltan, while Sam, Rob, and me have very, very similar roles and similar background as cognitive neuroscience, Zoltan roles, he's also a cognitive neuroscience, but he's also a statistician. So for Register Report, or maybe for any editorial job, statistician role is crucial.
I'm sorry, we don't see your slides.
You don't see my slide? Oh yeah, because I didn't press share slide.
Okay.
How about now?
Much better. Thank you.
Apologize.
No problem.
Okay, so I'm going to start again. Okay, so this is me, and this is my co-author. So I'm starting. So you know the faces. So this is Christopher Chambers, this is Sam Schwarzkopf, this is Rob McIntosh, and this is Zoltan Dienz. So you know the faces behind the people in Cortex. And I think we have a new member of team that just joined us last week. Okay, so even though I understand there's quite a lot of introduction to Register Report and Open Science Framework, I will just do a quick introduction again. And before I start with the talk, I will just say that this talk by and large is plagiarized from Christopher Chambers' slides. So a lot of the things that you'll see here is basically his slides. So as you heard before, the challenge that faces science today, and specifically people in early career, but not just people in early career, is the massive pressure on publishing. So it's kind of publish or cherish. And it's not just people in early career, it's also people in fixed job. At least in the UK, we have research assessment exercise every 3-4 years. And if your department or you personally scored quite bad in this research exercise assessment, you can practically lose your job even if you have a permanent job. So the publish and cherish is not a fantasy just for early career to get the job, but it's also a reality for a lot of people, also in a fixed job, at least in the UK. And obviously, if you don't publish, it's very, very difficult to get grant on board. So a lot of grants depend on your track record of success. So what we're going to talk today is I'm going to talk about a bit revisiting what people have revisited before, but so I'll try and do it quite short. So what is the problem with everyday research practice in psychology and cognitive neuroscience? And I think it's go beyond practice in science in general. How study pre-registration might help, which you already heard. So I'm, again, just going to briefly go through it. And then I'm going to talk in quite a lot of detail about the register report procedure that we have in Cortex. I'm going to highlight some tips for successful register report. And then I'm going to give 2 cases examples of studies that I edited together with the team. Okay. So, typically, in the interest of doing good science, which part of research study should be beyond your control? Obviously, the results, because in good science, you ask a question and you want to find out the result and you want the result to reflect the reality. But in the interest of advancing your career, which part of research study is most important for publishing in top journals? Again, this is the result. So the result becomes the key aspect for you to be able to publish in key journals, because top journals like Nature and Science only publish studies that have fancy results. So maybe this is the problem, and this is the alien that's flying right by us. So there is an incentive problem or an incentive conflict between what is best for science. So science needs to be transparent and high quality research, and this should be regardless of the outcome or the result. And what is best for a person, or what is best for the scientist, and for them to be able to progress in their career or even to keep their career, they simply need to produce a lot of good results. So what is a good result? Good results obviously have to be novel, it have to be striking, it have to be clear, it cannot be messy. We know reality is very rarely clear. You must find a significant effect, and we heard from the talk before, a significant effect is somehow set on this random number of 0.05. It have to work, so you have to be able to predict your result. It have to be shown convincingly. It have to majorly advance the field. It have to be definitive. It have to be beautiful. It have to be breakthrough, and it have to be high impact. So all of these things are really crucial to make a good result. And when you publish in high impact journal, you really have to convince the reader and the reviewers and the editor that your result match all these criteria. Given that we're working with quite a lot of intelligent population, which is scientists, they find a lot of loophole on how to make your result look better, so you can actually get the publication. And I think, as was said before, given that I'm part of the community, I'm not blaming anyone. I can admit to doing few of these bad practices myself. So the first thing is that there is a publication bias. We don't want to publish things that are negative or results that are very complex, because then editor and reviewer do not understand, and then you have a null result, so there is absolutely no story to tell. We do significant chasing, so we try to smooth the data and pre-process the data and massage it until we get the p-value to a normal level, to the level of acceptance. We then do harking, which is hypothesis after results are known, which is basically telling the story to match what we find or to make it more clear, so there'll be a clearer streamline and it will be easy to understand. People often don't share the data, and they don't share the data because there is no incentive to share the data, because sharing the data and organizing in bid formats and uploading it and clearly coding it is a lot of work, and there's absolutely zero incentive of doing it normally, although today there are data papers which could give you incentive. And one of the problems, especially maybe not with EEG, but mostly with MEG and MRI, is that it's a very expensive methods. And these expensive methods means that we have a very strict limitation on how much we can use them. And we often run studies with low statistical powers, just because it's too expensive to run these studies. And the final problem is that we don't replicate, because replicating is not novel, it's not exciting, it's just describing what someone have found before you. And if I'm just going to reiterate it, so if we look at the cycle of science, or the cycle of the positivistic thinking, which is underlying all science activities, we should have start with generating a specifying hypothesis, design a study, collect the data, analyze the data to test the hypothesis we said, interpret the data, publish the experiment, and then generate some new hypothesis. And you can see that in every step of the way, scientists have found ways of bypassing and loopholing and shortcutting and improving their chances of getting their data published, and improving the chances of getting positive results. So the rationale behind register report and register abstract in the same way is that because we place too much importance on the results of the experiment and not enough stress on the process that produced them. So result makes science exciting, but judging the quality of science and the quality of the scientists according to the result condemn us to being a soft science. So the idea to fix it, or the rationale of fixing it, is basically instead of focusing on the result in the process of accepting a paper, is we are going to focus on the question, on the methods. So we're going to focus on the question we ask, we're going to focus on the quality of the method that is used, and we're not going to focus on the results when we're accepting a paper for a publication. So in this case, if we accept this philosophy, the editorial decision at the journal should be blind to the result. So in pre-register report in Cortex or in any other journal, you're basically accepting the paper in principle, like for example, Sophie have presented that her paper was accepted in principle, and it was only based on the question and the quality of the methods, and none of us know the result because the data is not collected. And the result it doesn't matter. So this is the register report. So this is the paper that was, or the method, the procedure that was suggested by Christopher Chambers. And there are 4 central aspects of register report model. So researchers decide the hypothesis, experiment procedure, and main analysis before data collection. And part of the peer review process takes place before experiments are conducted. So if you pass this stage of review, then you virtually guarantee the publication. So you get an in-principle acceptance, and then you go and start collecting the data. And then register report, at least in Cortex, accept both original study, but also high-value replications are welcome. In Cortex, I think we only accept register report of study that the data was not collected, but there are some other journals that actually accept registered analysis, basically, of data that was collected, but you didn't analyze it yet. And I think even in Cortex, we have an initiative together with the ABCD data, where it's a large data set that was collected. So before their second release, which I think happened in March, people were invited to submit suggestions for analysis. But in that case, it was clear that they could not see the data before. Okay, so here is the process. So authors submit stage 1 manuscript with introduction, proposed methods, and analysis. And if they have some pilot data, then we have an editorial triage review. So basically, the 4 people you've just seen the picture, the 5 people, including me, look at the paper together. Where one of us basically lead this stage. Then if we are happy with it, we then send the paper to stage 1, peer review, and then people from the field will review your paper. And if the review are positive about the paper, you get in principle acceptance. So one of the things I want to do is, and I focus on it a bit more, is about the editorial triage review and where things we have a problem. So what we basically look at is we look at, are the hypotheses are well-founded? That's also the review looks at. Are the method and proposed analysis feasible and sufficient in details? Is the study well-powered? And have the author included sufficient positive control to confirm that the study will provide a fair test? But I'll go back to that in a second for about tips for writing pre-registration report. What we find is about 70% of the paper are rejected from the editorial triage review. It's very rare that the paper that is submitted to us does not get an initial rejection, which is a bit pity because that stage could be saved if the author follow clearly the guidelines that we specify. In recent months, we've becoming a bit more stringent because the format have become very popular. So these days we will reject but not invite to resubmit if the paper is clearly not following the guidelines that are specified for pre-register reports. But I'll go back to what needs to be done. Okay, so once your study is in principal acceptance, where a SOPHI study is in at the moment, you basically go and start collecting the data. Usually what we'll do is that studies that have been in principal acceptance are automatically have a link to Open Science Framework, and the protocol and the study is published on Open Science Framework, or at least is put there, but I think it's not necessarily being published and depends on the embargo that the author requests. Then the author do the research, and the author submit a complete stage 2 manuscript, which will include the introduction and methods, and this is virtually should not be changed. And then the results, which is in the use section, and register confirmatory analysis. And if the author want, they can also report and register exploratory analysis. There is a discussion which is new, and then the data must be deposited in public archive. Again, the paper is sent to the reviewers. We're hoping that will be the original reviewers, and they will just simply check if the author followed the approved protocol, did the positive controls or the neutral outcome was successful, and are the conclusions justified by the data, and then the manuscript is published. This stage is really just to check that things have done as planned. But papers are not being rejected based on the result of the papers. So what does it do? Basically, the things that we make sure that do not affect publication is whether the hypotheses are supported, so whether the results support the hypothesis, whether the p-value is significant, whether the results have an impact, that is not a criterion, and whether the results are novel, this is again not a criterion. But what does matter is that the hypotheses are clear, the study is powered, is well powered, the method is sound, and the quality of the data is good. So now I'm moving to some practical suggestions. And when we reject things at the triage editorials, what are the tips? And these tips basically are available online. So if anybody's planning to submit a register report, I strongly advise you to read the guidelines very carefully and follow them. This is not very clearly. Sorry about that. Okay. Can you see, or shall I try and make it clear? Sorry, I didn't notice that the color is, okay, I'll just read. So the cover letter. So the cover letter need to include explicit mention that you have ethics, that there is a clear procedure to archive the data online. Okay, cannot read the text. Yeah. Okay, let me fix that.
Now we can see that. Only one.
No. You can't see the text. Let me fix that.
Okay.
Sorry. I don't know why the text is coming in a different color than. Okay, I'm going to try again. No. I'm not sure why the text is not visible. because it is white on my screen. Maybe I put it orange. No, white. I don't know. Yeah, it is white on my screen, so I'm not absolutely sure why. I mean, it's not white when I'm presenting, but it is white on the slide.
Yeah, but I think you can read and then maybe
I'll just read. Yeah.
Thank you.
I mean, I think I shared the PDF, so you can just have a look at the PDF. Okay, so so the cover letter, you need to have an ethics before you submit. You need to have a clear plan of how you archive the data to make it open access, and the protocol have to be registered on Open Science Framework. Or you need to say how you're going to register it, but we can do it straight after it's in principle accepted. Method is a big thing to have a look at. So often there is insufficient details. If you heard from Sophie, when you actually look at the methods in a lot of careful details, there's a lot of free parameters that people often don't spend time on specifying, especially also with EEG, but any study. A lot of the time, there's no clear correspondence between the hypothesis, the experiment, and the analysis. And then there's the power calculation. So power calculation have become a big thing in register report, and we have, and in our team is basically Jens is helping us a lot. So one of the challenging is that people often do not define realistic effect size. They just throw an effect size, which we used to a lot of time doing grants. Oh, we think it's about medium. Oh, we think it's about weak. Oh, no, it's very strong because this paper show it very strong. So that's all the things will not fly. We really need a very clear justification of effect size, either based on pilot data or based on a very clear multiple papers that have done it. Usually we're looking for alpha, which is 0.02 or below, 0.02 and power of 90. And a lot of time there is no clear mapping between the hypothesis and the power calculation. Another problem is null results. So often if people predict null results, or if the literature is really mixed, so some find positive effects, some find opposite effects. So it's become very challenging to predict a realistic effect size. And what we do in these cases is that we usually ask you to compute a power calculation using Bayes factor with 50% chance of obtaining no difference. So basically, especially if you're predicting null results. So you cannot predict null results and use frequency statistics to power your study. And then another trivial thing is that people do not add neutral outcome condition, which is a very crucial component of register report, because we need to have some validation that the quality of the data is good. So we need some way to say, actually, if there is no result, it's not because the data is really poor. So a neutral outcome condition is a very important aspect to pay attention to. Oh, sorry. Here it is. Okay, that was a very stupid on my behalf. Okay, so now you can all read it because it was animated. Okay, some practical tips before we move to the case studies. My first practical tip is to keep it simple. Have a very clear hypothesis and a very clear effect, and make it a priority or the primary effect. Now, if it's not a replication study, then you really want to run a pilot study with few participants to be able to assess expected effect size. Because if it's a completely new study and new design, as you probably all know, new studies and new design all have unexpected problem coming up when you start running the study and you start analyzing it. So running few participants, 5 or 6 participants, will allow you first to iron out the method and have a very clear idea of what exactly you're going to do and what's the step you're going to make and where are all the decision points you need to make a decision about. So it will help you. And it will give you some data to compute effect size, which will be directly relevant to your study rather than trying to guess from the literature of things that are similar. If you are doing a replication study, we will strongly advise you to contact the original author for an advice and for unpublished tips on the study you're trying to replicate. we usually, whether you contact or don't contact, we will seek the original author to give a review, to provide a review for the replication study. So if you start this conversation beforehand, it could save quite a lot of going back and forth. When we come to power calculation, one of the challenges we have, which we need to solve, is that if we have a multifactorial design, which we often have, and it's an often repeated design, which most MEG and EEG studies are, there is no existing tool to calculate the power for such a design. So there is no existing tool to calculate the power for multiple factorial design, and especially for interaction in multiple factorial design. So one of the things and the fact that there is no existing tools is not gonna, it's we still need a realistic power calculation. So what we advise also to do in cases like that is basically to reduce the hypothesis to t-test. So if it's an interaction, you can either compute the difference between the difference and then see if the difference between the difference is significantly different than 0, so you make it a t-test, or you have a specific hypothesis on simple effects which are part of the interaction. So you need to think of how you're going to reduce your multiple factorial design to very simple question of comparison between two conditions or comparison of condition against 0. Another thing is that you really want to choose what is the most important question and make it the primary question. So it's good to have one, maximum 2 really important questions. These will be your primary question. You focus on it, you do your power calculation on it, you have a very clear idea of what you're trying to do. The other question can be made secondary or can be made exploratory, which in some cases you can report on it in the register, but you're saying this is an exploratory plan, or you can just simply add it at a later stage in stage 2 under exploratory analysis. But really keep it simple. That will make your life easier and our life easier. So now I'm going to move on telling you about 2 examples of register reports. So the first study, which is I think one of the first MEG study that we had, it's basically look at the effect of AMPA blockade on the spectral profile of human early visual cortex recording studies with non-invasive MEG. So basically the question was very simple. If we give a GABA blocker, will that have an impact on gamma oscillation? So what kind of challenges, what did we learn from that study? So the first thing that I learned, and I think it's a very good lesson to everybody, this was a very high risk and costly study because it involved people coming twice to the lab. It's involved intervention, basically drug intervention. It's involved an MEG. So that's a very, very expensive study to run. And if the result of the study would have been negative, basically they would have found no effect, they would have very difficult problem to publish the study, given the culture, the existing culture. So from their point of view, if you are planning to run a very high risk and costly study, I think it's a no-brainer to register it in advance to just guarantee that you actually end up making use of the investment of time and resources that you put in. Another thing is that the theoretical question was very straightforward. Yeah, are gamma band oscillation associated with the glutamatergic principal cell? And one of the issues we had is, for example, how much drug to give and what should be the outcome of neutral criteria. So these are a few of the issues that we have to go back and forth with the authors and with the reviewers. Another thing that came out is at the end of the day, the author found that actually there was no relationship between glutamatergic cells and MEG. And the reviewers were not happy with the results. So the reviewers were really suggesting a lot of new registered and non-registered analysis and a lot of things to change the results because they thought the author did not do what they should have been done. And I think at that stage, as editor, we stepped in and we said, no, the author does not have to do anything they don't want to do, like they didn't register in advance. And in that case, what we do is we offer what we did is that we offered the reviewer a chance to basically, given that the data is out there and open, we told the reviewer, so if he wants to analyze the data, he can go and analyze the data, and we basically guarantee that we will publish it as a comment. So I think, so beyond educating the authors and the researcher, we need to educate ourselves as reviewers as to be open-minded and understand what it means to be to have a study registered. The second study I want to talk about is a study that again is an EEG study, and I think what they try to do is they look at alpha phase in human perception, and specifically they ask whether a spontaneous pre-stimuli low oscillation phase is kind of the gatekeeper for perception, which I think is a fact that has been published by a few labs, and especially Van Roolen's lab. So they literally want to replicate the effect that published by Van Roolen and by other people. The neural outcome condition was basically looking at the correlation between pre-stimulation alpha power and detection rate. So that will kind of guarantee that their effect will be, that the data is basically matching something that is very, very robust. So again, the theoretical question was simple. It was a straightforward replication, but I think, as Sophie said, you never get straightforward replication. The author have discussed with Van Roolen before the registration or during the process of reviewing, and he definitely gave a lot of tips, and I think he also shared his data with them. They had a secondary question related to inter-subject reliability, which depended on the fact that they will find a positive result in the initial state, that actually a spontaneous phase of the oscillation, alpha oscillation, will predict perception. So one of the issues that we came across is that reviewers thought the findings are robust, and there is no need for replication. So we have few reviewers that were very, very negative about this replication, arguing that this finding is absolutely robust in the literature, and it's a waste of time to try and replicate it. And you can obviously imagine that actually the author failed to replicate it. I think the fact that the author failed to replicate it was obvious from an editorial point of view, that it was not an easy experience for them. It felt like the author was very, very frustrated that they did not manage to replicate the effect they predicted, or the effect that the literature predicted. And you can feel that they went and did a lot of effort to try and find out that indeed they have failed to replicate. Another thing that they did is that they went and used the exact parameters of Van Roolen analysis and Van Roolen specification, and I think they even used his code to see if they use exactly his parameters, would they be able nevertheless to replicate his effect in their data, and they still failed. One of the challenges that we found with this, and again, I don't know if it's directly related to the result they found or it was just by chance, but none of the original reviewers agreed to re-review stage 2, which is a bit of a problem, because then you're bringing on new people that did not approve the register analysis, and they always have different opinions. So we had to approach different reviewers for this stage 2, which made the process much longer than we wanted it to be. And also educate the new reviewer of stage 2 that the author should not go and do anything that they have not registered before. So that was a bit of a challenge. Another challenge that we have with this paper is that because the replication failed, the secondary question became irrelevant. So a big chunk of the methods and a big chunk of the introduction, which talk about the inter-subject reliability and the inter-subject and the ability to replicate the effect beyond a session, become completely irrelevant because the author did not run this analysis. So what we decided at the end, that we move all this part to the supplementary material, and by that we actually end up changing the methods from the original methods. And I think I will finish here. Oh, do I have more time?
Thank you. We have time for the roundtable, and there are so many questions. I'm really happy to see so many questions. So I see that there is a question that has 36 votes from Robert Ostenveld. So if the admins can bring him live, then he can ask the question himself. Hi.
Can you hear me?
Yes.
Good. So my question to the panel as a whole is, how should we prepare PhD students for doing a pre-registration while they're often still learning on the job? And so from my perspective, that I'm working with, that's part of the data. So it's like I totally support the idea of doing pre-registration, but also working in this academic environment where we're training, the question is how should we change the training such that we can do these pre-registrations?
Nice, thank you. Who would like to? Okay, Pia, please.
I think one of the things I want to say for both PhD and postdoc students, pre-registration is absolutely golden opportunity for them, because I think a lot of time with PhD and postdoc, you put all the work, you do all the data collection, you rush, at least in the UK, you rush to write your thesis, and then you move to your next postdoc without actually bringing the study to publication. But if you pre-register the study, at least in a journal, you guarantee that even if you move to the next step, you have a publication, and you can write in UCV, I have a publication, because it's in principle acceptance. So you shift the time, I think as Sophie said, from after the study finished and then trying to roll through various journals, you've shifted to the time you still have a job and you still have something to do in UCV. So I think from career-wise for young people, it's actually a very useful way to get a publication, and what you need to do is you push your supervisor to do that.
Very interesting perspective. So there is Ronnie, would you like to say something?
Yeah, I just want to add that during while you write the pre-registration report, this can involve a lot of hands-on experience as well. So you can run simulations and you can run the analysis. So it's not that you just do some theoretical work and don't get to work with actual data. So another way to kind of incorporate this in training would be to really use data while you do the pre-registration.
Yes, please, Sophie.
I'd like to, I fully agree with what Ronnie and Pia said, and I would like to mention again the aspect of pilot data. So I think without pilot data, it's not possible to come up with the pipeline, and it's much better actually if you record your data when you already work with data, so you really know what you're up to and what artifacts look like, and that you can get rid of them. So I think it can even improve the quality of the real study. If you have, you can learn working with, I don't know, I had 3 pilot subjects. But what worries me more for the early career research is the timeline. So I agree that we can shift from the late to the early time. But for example, a master's project in France, it's 6 months. So I don't think we would have the time to do at least not a registered report. We could do a pre-registration on OSF or something, but we don't have the time to wait for a peer review. So I don't know how we could address this problem.
Yeah, perhaps that could be a solution. Perhaps a solution would be to embed in the training pre-registration, not registered reports necessarily, but then as soon as the PhD starts, then there's already enough knowledge of how to pre-register a study and what to put in the pre-registration, that the process is much more, much quicker. I think that could be a good solution. So Robert, are you satisfied by the answers?
Yes, I'm definitely satisfied. I just was like thinking to type it. Perhaps I can also say here, like one of the strategies that I often use is trying to find an existing data set that is similar to the data that the students are going to work with, and have them work through the analysis on the existing data sets to simply speed up the process of the learning. But yes, I totally agree. Thanks for the insightful comments.
Thank you for the question. So now we have another highly voted question by Yarden. I will read it. Isn't a presentation? This is a question for Ronnie. Isn't a presentation of an idea in such an early stage risky, meaning that others might run your experiment or publish your idea before you do? Especially when you talk about
the problem of the problem of scooping research. So I guess there are two levels for this. So one is that actually putting your stuff out there kind of protect you from scooping, because then you can go back to the conference or to the program and show that you actually were the person who had this idea first. Having said that, however, I'm not sure that this would be kind of a valid court argument to take your abstract and to show it. And in most cases, you will probably just end with a frown and be just really mad about being scooped without much ability to do anything about it. I still think that the potential benefits of this outweigh the danger of being scooped. Like the idea that you can get a lot of feedback on your study at a very early stage, in my view, it's more important than the, I think, unlikely fear that this might happen. But of course, there's no perfect system, and this is not a perfect protection.
Yeah, so I would like to add something to this, because I hear this very often. So I'm also a researcher. I've been a researcher for 10 years now. I'm not officially a researcher anymore, but I'm still digging into science. And I hear this from colleagues very often. Like, I don't want to pre-register. I don't want to share my data. I don't want to do this or that because I'm afraid of the consequences. But actually, if you look at what we know so far, the consequence of being scooped, like the actual instances of being scooped, are extremely rare. And very often they come out and it's really a terrible look on the person who scooped. So it also bears some costs to scoop. Now, I don't want to generalize. Of course, I'm sure there are like specific instances, but I think that we are talking about tackling a fear rather than tackling like real events when it comes to scooping. Does that make sense? It does make sense, maybe. Okay, cool. Well, thank you. So there is another question, this time for Sophie. Is it okay to register your hypothesis after seeing pilot data? What if you already see patterns that may bias your hypothesis?
Okay, I should clarify that. So I did not look at the comparisons that relate to my hypothesis when I analyzed the pilot data. So this was more for getting an idea of like outlier, how long are reaction times, what do I need to exclude, e.g. pre-processing. And in my case, since this was a replication, I already had the hypothesis before I even started that. So I don't think it is a bias, and I don't think you can necessarily do the group analysis. And B, I forgot my B. Sorry, I think about. That's maybe fine. Pia can comment more on that because there's more experience.
Yeah, can I comment?
Absolutely, yes.
I mean, one of the things you can. So first, pilot data is not enough to justify the hypothesis. I mean, the hypotheses are justified by the literature and by your theoretical assumption. And the pilot data can just show that you are on the right track. I mean, if your pilot data going opposite direction than the literature, that's another matter, but then you may need to get a bit more pilot data, or then you maybe need to predict a null effect and do a bias, basically use bias factor to predict a null effect or an opposite effect than what the literature goes with. So there's no problem looking at the pilot data. The pilot data anyway is not going to directly contribute to your new data and does not contribute to the power of the new data. So the whole cycle of positivistic thinking is that you collect data, you do analysis, you form hypothesis, and then you move on. And your hypothesis could be, okay, I want to see if what I've seen in my pilot data is actually holding for a larger group. There is no problem in that.
Yeah, yes, please, Arnie.
Yeah, I think one good use of pilot data is to actually establish realistic effect sizes. So you can run your pilot, get the effect size from that, and from there we're registering study with that.
Can we really do that? I'm doubtful about that.
Yeah, you can do that. Yeah, no problem. On the contrary, I mean, it's recommended.
So this is something that also, was interesting, and I would like to discuss with you because Pia, you mentioned it in your discussion in your presentation. So how can we trust pilot data to identify realistic effect size, or maybe not realistic, but like precise enough that we can actually expect something similar when you have a larger sample of the population?
I mean, so first, again, as I said, pilot data by itself does not stand on its own, right? But a lot of time, every experiment have its own nuance, and finding data from the literature that match exactly your experiment is very challenging. So just running few participants to estimate your effect size, if it's following your direction, then that's the best you can do. And yeah, we definitely accept people estimating the effect size based on the pilot data they have.
Yeah, no, I understand this. I don't want to make it like too long of a topic, but perhaps if in the literature, if a particular register report cannot provide a reasonable estimate of effect size, it's probably because in the literature there is not enough specificity, there is not enough precision, and so probably that is not necessarily a register report, because we're not really sure of the kind of hypothesis, or like the hypothesis that we're trying to investigate is not very strong. So maybe could it be something more suitable for an exploratory report that I know also at Cortex is proposed?
Well, I mean, I guess it's depend on the authors and how do you want to approach their research and frame their scientific question. But I can clearly say that we will accept effect size based on pilot data. But if you feel not confident about the effect size that your pilot data producing, yeah, you should go to exploratory report.
Perfect, thank you. So another question by Elena, I'm sorry, I can't really pronounce well. So for both Sophia and Pia, how detailed data analysis should be provided for a registered report? Will it be enough or not enough to just list all steps of an analysis? And if it's necessary to go deeper, is it even possible to do registered report with analysis in Brainstorm, or only M&E and other script languages are considered? Sophie, Pia, any?
I mean, I think because that's where pilot data will help you a lot, because I think what you really want to detail it enough that anybody that need to replicate it can do it, can realize every decision you took throughout the steps. So you really need to kind of unpack every step that you do and make sure that it's clearly the decision are made, or if not the decision are made, at least you put a very clear criterion of how you're gonna make these decisions. Yeah, so it has to be fairly clear. So there's a lot of free parameters, especially in imaging, for example. How are you going to choose your electrodes? How are you going to choose your frequencies? How are you going to choose your time windows? All these are free parameters that you need to decide. So you need to have a very, very clear mechanism by which to make this decision a priori, and not to leave it to the person who analyzes to make the decision as it go about. That's what we really want to try to prevent. That when you analyze the data, there is no free decision that you can do either that or that, depending what's look better.
Thank you.
Yeah, maybe to add to this, I think at the point I tried to make in the end, I think this is really a difficult question, because there's so many details that it is tedious to, first of all, think of all of these points and to report them and to define them a priori. So I think that's a part where the research community could discuss better options. For example, what I tried to mention was instead of saying we have a fixed cutoff where we throw away epochs, we design a criterion for SNR or something. We say we remove epochs until we reach this criterion, which is of course independent from the actual comparisons that we want to do. So maybe there could be some methods development, or in this direction that makes it easier.
I mean, in some pre-register report in the for EEG and MEG, for example, we do power calculation for also individual subject, how many MPEGs you said. So you do have to say, okay, this is how much I think I'm going to lose from a point of view of data quality, because there's a noise in the data, and this is how much I need to be stayed, and this is how much I'm likely to use. So a lot of time power calculation on number of trials per conditions are also thrown into the power calculation estimation.
Thank you. So there is another question. I mean, if I remember correctly, we have time until 5:45. So we have so many interesting questions that I just keep going. Like somebody has to stop me. This other question from Virginie for Sophie or everybody, whoever feels like answering. Should pre-registration become a mandatory first MEG or EG study for trainees? Should pre-registration be mandatory? Who would like to answer to this?
Well, I would say yes, but I would think a better way would be to say pre-registered replication would be a good start for a PhD project. And what Ronnie said, I think it would really help people to start like going to conferences early on without having data, and it could really improve their interaction with the scientific community. I think it would be quite difficult for someone who's new to pre-register a completely new study, predict power, effect sizes, pipelines, but starting with the replication and pre-registering it to make sure you go through the process before you actually do the study sounds like a very good idea to me. And just my recent experiment showed me that it's not trivial at all on a theoretical level. So you learn a lot even by doing the replication.
Oh, you said something that makes me want to ask you a question. But first, let's see if somebody else from the panel. Yes, please, Ron. Yes.
Yeah, I don't know if mandatory, but I think one thing that can work would be if this is incorporated actually in funding applications, in grants. So you get the money following pre-registration, and then once you hire a PhD student, then there's already a protocol to follow. And then, for the subsequent experiments, they can write their own pre-registration, but to kind of incorporate this at the previous stages already.
Yeah, absolutely. Okay, so I'm sorry, I just have to ask this question. Sophie, like you mentioned earlier, like you also were particularly struck by the fact that the theory behind the experiment that you were trying to replicate was also like, it was challenging to delve into that as well. So my question is, and it can be controversial, so please be careful how you answer. Do you think that pre-registration can help with theory development?
On an individual level, for sure. I think it can definitely help you as the experimenter to solidify your theory and your question. How much does the community benefit from it? Well, I think in my case, it resulted in a clearer introduction and a better specified alternative outcomes or sanity checks, and that can definitely also help the community. So I think yes. And it's also, in my case, I think the field advanced since then. So that around this delta oscillation, it's a big question is whether we're actually really looking at an endogenous oscillation or whether it's something like evoked activity, because delta is so slow, so things might get smeared back in time and might actually, the pre-stimulus effect might come from a post-stimulus evoked activity. And I think the field has moved on, and this has, it's also a reason for me to replicate this study, that I want to have these data in my hands.
Perfect, thank you. So we've got like 3 minutes. So I think, I mean, there are still 10 questions here. I can't possibly ask the panel to answer all these questions, but thank you so much for being so engaged. Okay, ask one more. Okay, sure, let's ask the last question. So Vladimir, this is for the whole panel. Since in new MEG or EG studies, pre-registration is challenging because there are no highly standardized pipelines for many analyses, wouldn't it be a good idea to have a 2-stage process where studies that the research community sees as important are upvoted for pre-registered replication, and then we also have a mechanism to fund that? this is wow. This is systemic. Who wants to answer this?
So what platform would you use for this kind of avoid? Like, I can imagine how this.
I can just say that I heard a rumor that actually the EEG community is being geared up to like what psychology have done with science. There is a gearing up in the EEG community where multiple labs collaborate to replicate seminal funding. So I think this something has come up through, you know, grassroots and community that basically come together from different labs and identify key studies and go and replicate them.
Yeah, it's the EEG many labs
initiative. Yeah, exactly. We will hear about this during the conference. Yeah. Yeah, so I think this is a big question that, you know, I don't think we can possibly answer it like in 1 minute because it also requires, I think Ron, you mentioned like how to have like a platform that allows you, because there is somebody for the EEG Many Labs project, if I understand correctly, there is a group of people who has decided more or less what kind of what studies to replicate in these large scale replications. I think this is more like this idea that was posted here was a bit more like a crowdsourcing even the ideas and then be like, okay, so now that the majority of people are really interested in this particular question or in this particular application, then we go and fund this. I don't think we have a system, as far as I know, for this, but that would be great. I'm sorry, but we just have to stop this. This has been very, very nice, very exciting. And yeah, hopefully, the experiences that were shared here in this session have convinced the audience that pre-registration is a valuable practice that can be part of your, standard tool of practices. So I would just like to thank everybody for attending. Thanks to the speakers. You have been really, really nice, and it's been really informative. And thanks to the organizers for organizing everything.
Well, thank you very much. Thank you for the high quality talks and the very nice sharing and the discussion. Thank you, Antonio. So it's almost time to go to our poster sessions and social events. So I'm going to show you the Gazetown platforms that we're going to use for this. Let me share my screen. And give you a few tips. Then I will, after that, send you the link so you can go check that yourself. So here, can you see my screen? Okay. Hi, Manuel. How are you doing? So this is my character here. So you will notice that we do have red caps. So how did we pick that character? Let me see. I don't see the lower part of my screen here. So if I go down here and I have a change character button. I can change my cap, I can change my hair, I can change my clothes. Please let us use this red cap. So all of the organizing team will wear that red cap with the white 3. So you can just come to us and ask if you're lost. We'll answer your question. As soon as you step on this textured carpet, you will enter a private area, which means that you will be able to see and hear all of the others that are actually stepping on that carpet. Here you can see some of the objects. Here, let me step on this. I have to press X in order to see what's in the object. Here, a small documentation, but we'll also send you a short one as well. Let me go to the next room. Here, let me show you the main hall a little bit. Feel free to go on the stand. Again, to enter, you press on X. Feel free to go check the job board and edit. So here you have two carpets for discussing about these two sessions that we heard today. There will not be any keynote today. And if you want to go fast, so you use your arrows, and if you want to go a little fast without interacting with others, you can press the G button, and that way you can just go straight to the poster you want to see. So here is the poster room. Hi, Max. Let's follow Max. And here I want to go on the 39 poster. We'll send you the poster list, or it's already been sent. If I want to check that poster out, I press on X. So the speakers, the presenters, shall stand next to their posters at the right time schedule, and they will be able to interact with others. Here on the right hand side of the screen, you can see all of the participants. So please make sure you use your full name as your pseudo, so that people can find you. And if I click on this character, Manuel, for instance, so let me close the poster first. Let me step back and let me see if I can locate Manuel here. And I follow the red path, and this should bring me to Manuel, but he's maybe hiding. So let's leave him alone for now. So I think you're good to go. I'll send you this link right now. I hope to see you on Gazette Town, and I hope we're gonna have fun. I'm sure about that. See you soon.